Hi Platypus! Welcome to Platinum, where future topnotchers are made. I am Mecca Salimbagat and I'm the reporter. And today we'll explore lipid-derived hormones, those powerful little messengers made from fat that control everything from your stress levels to your bones. Now, come on and join me as we make our journey to Top 1. What are lipid-derived hormones? What are they? These are hormones made from lipids like cholesterol and fatty acids. And even though fat gets a bad reputation, your body literally depends on it to make hormones that regulate essential processes. They help regulate stress, mhm, metabolism, reproduction, inflammation, and more. Without them, oh, you'd probably faint during finals week, or even worse. And now, let's break them into four main classes, like the four houses of Hogwarts, but instead of Gryffindor and Slytherin, we've got first, steroid hormones, second, icosanoids, third, vitamin D derivatives, and fourth, endocannabinoids. So each has a unique structure and superpower. Let's zoom in on the steroid first. So, steroid hormones are like VIPs of the hormone world. They are made from cholesterol and it includes cortisol, your stress responder, aldosterone, your blood pressure balancer, testosterone and estrogen, the hormones behind reproduction and puberty. But of course, there's more. They're actually grouped into three families. So we have glucocorticoids, including cortisol, controlling metabolism and immune response. We also have mineralocorticoids, including aldosterone, regulating fluid balance. We also have sex hormones, testosterone, estrogen, progesterone, overseeing reproduction and secondary traits, sex traits, of course. But where do they come from? Well, they come from the adrenal cortex, gonads, and during pregnancy, even the placenta. So let's break it down. Steroid hormones are synthesized from cholesterol, a lipid molecule with four-ring structure. Once your body receives a signal, say you're stressed, enzymes in the adrenal glands convert cholesterol into cortisol, the stress hormones. And what's cool is how they work. Steroid hormones are lipid soluble, so they glide through cell membranes like a VIP bypassing security. They enter the nucleus, binds to DNA, and tell your genes to make specific proteins. So yes, they can literally change your body's behavior from the inside out. And in simple terms, they change what proteins your body makes, and that's how they influence things like metabolism, inflammation, or muscle growth. And I'm asking, why is that important in real life? These hormones are slow to act, but their effects last longer, which is why one dose of prednisone, a synthetic steroid, can reduce inflammation for days. In the lab, we test cortisol for diagnosing conditions like Cushing's syndrome, or too much cortisol, or Allison's disease, too little cortisol. So, the next one. Oh no. Yes, quick quiz. Which organ produces steroid hormones? A. Liver. B. Gonads and adrenal glands. C. Pancreas. Yes, the answer is B. Gonads and adrenal glands. Now, meet the icosanoids, the body's emergency responders. Unlike steroids, they don't go far. They act locally and fast. We are talking about inflammation, pain, fever, blood clotting. And they are made from arachidonic acid, a fatty acid in cell membranes, and includes prostaglandins, leukotrienes, thromboxanes. Ever taken ibuprofen? That works by blocking prostaglandins, like they go boom, less plain swelling. These guys don't circulate in the blood like steroid hormones. Think of them like firecrackers. They have this boom effect and it's already done. And then the next one again, pop up question. So, why are icosanoids short-lived? Well, the answer for that, it's because they are broken down quickly, making them perfect for fast, local responses. Hmm, Vitamin D? Yep, it's technically a hormone. It helps your body absorbs calcium and supports your bones. After sunlight hits your skin, your body transforms cholesterol into calcitriol, the active form of vitamin D. So after sun exposure, it is converted in the liver and kidneys into calcitriol, the active hormone. And then calcitriol regulates calcium absorption and bone health. Without it, you might get rickets or osteomalacia, making soft and weak bones. And we have, last but not the least, endocannabinoids, your body's natural calming agents. These come from fatty acid derivatives like arachidonic acid, and it includes anandamide or ananza, or equals to bliss, also including 2-AG. Yeah. So they bind to receptors also targeted by cannabis, CB1 in the brain, CB2 in the immune system, regulating pain, stress, appetite, and your mood. And guys, I have a fun fact here. Your body makes more of this during exercise, sleep, or meditation. That's your natural chill pill. So basically, these hormones show up in clinical diagnostics all the time too. Here's where you'll see them. So steroids, hormone panels for adrenal and reproductive disorders. We also have vitamin D, bone density problems, icosanoids, inflammation markers, and last is endocannabinoids, being explored in pain and anxiety and research. Anxiety research, yes. And let's say your patient has a moon face, high blood sugar, and purple stretch marks. Ding ding ding! That could be Cushing syndrome from excessive cortisol. And how about they are always tired, craving salt, and have low blood pressure? Let's think. It's Addison's disease, wherein cortisol and aldosterone are too low. Or how about a child with soft bones or delayed growth? You'll probably run a vitamin D test to check for rickets or osteomalacia. How about someone sneezing and wheezing a lot? Let's check for leukotrienes are likely involved. That's why leukotriene inhibitors like montelukast exist. And while endocannabinoids aren't routinely tested yet, they are being explored for stress, PTSD, and chronic pain management. Now let's tie it all together. We have hormone class, their example, and their clinical use test. We have steroids, its example is Addison diagnosis. We also have vitamin D, calcitriol is the example, bone health, calcium absorption issues is the clinical, and then icosanoids, its example is prostaglandins. Then we have a clinical, inflammatory marks NSA response. We also have endocannabinoids, anandamide 2-NG example, and this is for future studies on stress, anxiety, pain. You'll likely see this in lab test results or case studies during your internship. And guess what? You'll be the one helping interpret them. So yeah, these hormones aren't just science. They are your future daily grind in the lab. So remember, strive, excel, succeed. This is Platinum, where future top notchers are made. See you in the next review. Bye!